Hey, what's going on guys, Kamikaze here. In this video we're gonna have a look at text editors as the programs that do violate the Unix philosophy principles, believe it or not. So just before we start, a few words on what is the Unix philosophy actually. So it's the set of principles guiding a programmer to build modular software. Let's say just very general kind of definition, but just to give an idea, so you just imagine one big task. So there might be one big monolithic program that is solving that task. Or alternatively, this one big task might be divided and conquered by a whole lot of many tiny little modules, where every single module is actually doing its own part of the task. And what is even more interesting, and what's the most important about the Unix philosophy? So in case if you have this one big task split it into a whole lot of tiny little modules, the idea is that instead of only accomplishing this one exact big task, if you combine those tiny little modules in a different way, it may result in solving another and another and another tasks. So by having this set of basic commands or features, in theory you should be able to accomplish whatever tasks that do rely on these parts within their requisites. So the idea is that if you have the set of these basic commands, no one ever knows what kind of tasks you can actually solve with this. So the idea is the goal is flexibility. So with a monolithic approach, no matter how good the monolithic program is, it can only solve that big range of problems that is supposed to be solving, but only the one way that has been defined once and forever. While with this composability and modularity approach, you can in theory and hopefully in practice change the tasks that are about to be solved with this set of the initial basic comments. So one of the examples of how this works in the real life is the Unix environment, the Bash shell or whatever similar, where you have the core Linux utilities, for instance, I don't know, like cat, grep, whatever. So all those utilities have they can pipe data from one to another via the standard in and standard out, so standard input and output. So you can just cat the program, like cat means print, to print the program to the screen, and then you can use grep to filter that output and to print only those parts that you're interested in. So that's the core idea. And now we're coming to defining a few core principles that actually, a few core design principles that allow to achieve this flexibility. So the first and the most important principle is do one thing and do one thing well, do it well. And I would even add to this that not just do one thing and do it well, but do one thing at a time and do it well. And why I insist on saying do one thing at a time, because if you have a look at the shell scripts, they all are sequential. So the commands are piped like one after another, and it's really about doing exactly one thing at a time. And then whatever output this one thing does, it can be then redirected to the other elements within the pipe. So hope that makes sense. Now, deriving from this principle, like doing one thing at a time and doing it well, there are a few more derivatives. So trying to write programs that work with other programs, like the Unix, Linux core utilities are just a great example of that. And also interacting with the text. So instead of having some fancy APIs, just interacting via plain text. So standard input, standard output. So if you want to source something to the program, you just use standard input, and not obviously typing this from keyboard, but you can source the input from the file, for instance, and that's how the commands are getting linked in the scripts. And the same for the output. So output into the standard screen is not obvious, so you can actually output to the standard input of the another, to the input, output of the one program becomes the input of the another program. Storing the data structures as the plain text, storing files in the plain text. Well, it's a little bit not really to the point in regards to today's topic, but anyways, also kind of nice, good thing. And another quite important principle that people don't usually emphasize that much. And this principle sounds the following: avoid captive user interface. So what the captive user interface is, I'm sorry for such a little bit too long preface, but it's really important and essential to understand what I'm going to be showing in this video. So this Unix philosophy, it assumes that you are already in the user interactive loop, let's say like the bash shell, for instance. So you're already in the mode where you're getting prompted by the command line. So you issuing the commands into the command line, you're getting some output, you can compose some scripts from those commands. That's pretty much all about it. So you already have the environment where you're living, and that should be enough, according to the Unix philosophy, to do whatever, to accomplish whatever tasks. Just not leaving this environment. So in case, if you're running the program, well, for instance, let's imagine the program that prints your name. So you can say, you can call the program, and then the program can prompt you, like, what is your name? You say, you type in your name, hit enter, then program says hello and your name, and exits. So this is the example of the captive user interface, because you just got away from the shell, and instead you got captured into another prompt, so a kind of sub command line. So you're getting captured within that sub command line, so you're forced to type your name. So you're no longer in the bash shell, so you're already into some specific environment. And that's supposed to be a bad thing, because for that specific environment you need to know the specific commands. That's hard to remember, and that's generally violating the Unix philosophy. So an example of avoiding the captive user interface would be using your name as a command line argument to the program. So you just call the program, you just specify the command line argument to that program, then hit enter, and you're getting exactly the same output as the program says hello and your name. But in this case, you just avoided captive user interface. So in this video in particular, I want to emphasize two big principles. So do one thing at a time and do it well, and avoid captive user interface. And if you now have a look at the text editor, you'll realize that text editor is actually violating these two essential rules so hard that it's really hard to imagine how much they do it. So let's consider a very simple thing. So just list the current directory, there is nothing there. So I want to create a text file, right? So let's say I use a VI text editor, right? So I just call VI, it's actually alias to Vim, but it doesn't matter really. So let's count the actions that I'm supposed to be, before anything else, the very first rule that has been violated already. So I just got trapped into the captive user interface. I'm no longer in the bash shell, I'm in the text editor, right? So whatever I need to do now, I need to know the commands that are specific to them, and a whole lot of things that are the key bindings, and etc. I don't say that is bad, and Vim is like one of the best editors. It's actually the best text editor in the world, according to my opinion, personally. But anyways, it just does violate the principle of not using the captive user interface. So we have one principle being violated. Now let's see what happens in regards to the rule of doing one thing at a time and doing it well. So for instance, I want to start inputting some text. So I say like, this is line 1, right? So what am I doing now? I'm not actually editing, I'm just appending text to the buffer. So it's not really editing. So the first thing I can do in the text editor, I can append text to the text buffer. So I say this is line 2, for instance. Now, the second thing that I can do, I can actually navigate through the text. So I can view the text. So viewing the text or navigating through the text, right? If I say colon, I can use some specific commands, like go into line number 1, for instance. So, by the way, having the command line within the text editor itself is a double captive user interface, because I'm captured by the text editor that's one layer, and then I'm going to this to the command line that is within this captive layer, and I'm getting trapped twice already. So twice violated the principle of having twice violated the principle of not having the captive user interface. Then so we have two actions. We have append, we have view or navigation. Then we can, for instance, actually edit. So if I say R and just replace, or I say R and just replace the entire word. So the third thing is actually editing, because I do edit in particular. And here we can also say like delete and many things like that. So it's already append, navigate, edit. So 3. Did I? Yes. So it's 3 so far. What else? Well, even this is enough. So it's also already three things already. But on top of this, if say I want to save this file, so what I need to say write, and I can't even do this because I need to specify the file name. So we're coming into the file browser territory. So literally, I'm about to doing some things that the file browser is supposed to be doing, like creating files, right? So this is something that regards this, not the text editing differently. So it's another. So the fourth thing that text editor does, it does the file IO operations. So if I say just write and task.txt, then yeah, finally I write the file. So like a whole lot of violations already. So it's definitely like goes against the Unix philosophy so far. However, it doesn't say that the Vim is the best text editor, the best text editor in the world, anyways. But I've been thinking about this for quite a bit of time, and I was trying to realize, is there actually a way of how one can handle this? So how one can do something to try to violate less things than the text editor does. So trying to avoid being that monolithic, let's say. And my research was going as following. So the first thing I've realized that before this visual text editors, there were so-called like line editors. So like standard Linux text editor add, for instance, where we can open this tags.txt. And it just tells me that there are 29 bytes, I guess, there. So I can print, just prints only this line. So let's say I can print from, I don't even know, so to the end of print to the end of the line. I forgot the command, I'm sorry. Let's say 1 and to the end of the lines, and print. Yeah, so here I'm also captured into the captive user interface because I need to remember the commands that are specific to add. However, this is the only layer. Well, actually, not exactly. If I try to append text in add, I need to say A, and then I'm kept into another nested captive user interface. So I can say this is line 3, right? And then command to stop this, and then again from the first to the very beginning and print. So just append the line, and if I now want to write this to the file, I can do this just like in Vim. So again, like it's maybe a little bit better because I still have this feeling of like I can still see the previous commands from my bash shell, but anyways, it's still violating. So such a long preface is intended to demonstrate an alternative way of how one can actually edit text. The way so the Unix philosophy doesn't actually get violated. It's completely useless, pointless, and impractical thing. However, from the purist mind perspective, this might make sort of a sense. So I just want to quit. Can I? Okay, right, quit. Why can't I quit? Actually, Okay, sorry for this. Anyway, so we don't want this task.txt, just remove this. So what is important? So I'm going to be using Python shell. It's quite simple. So I'm going to be using the Python shell because let me even just like clear it Python 3 because the idea because the Unix philosophy itself is not really tied up to the certain environment. It's just a principle. So it prints like say avoiding the captive user interface. It means that you need to have some basic shell-like environment within which you can actually execute some pieces of like tiny little commands. It doesn't matter how exactly they look. It doesn't really matter that much. So let's get started creating some text files. So I will now be writing some simple program, and I'm not going to be writing the simple program like you would have expect me doing this like in the Python shell. Obviously you can do like line 1, line 2 and all that in the global scope, then you can just execute this. No, we're not going for this. We're going to be using the Python shell as the editor, as the text editor. So you might be wondering how on earth is that possible. So we'll start by defining the buffer. So buffer is the essential variable that we actually can work with in order to store our text, and then we can write our buffer to the disk, for instance. That's it, to save our work. So if I want to add a few lines of code, I can use the one-liner with the list comprehension. So I can simply say input, then for I in, let's say, the range of 100. So I can always press Ctrl-D to drop from that. So I don't need I'm not really forced to enter 100 of lines of text. So I can say, for instance, import requests, and actually I just make a mistake, and that's a good idea because I'm about to be showing the text editor. It wasn't intentional, but anyways. So from bs4 import beautiful soup, for instance. I just want to make okay. Yeah, so it's like if I press an enter, I just can't do a new line, obviously. Anyways, that just drop here. So what have I done? No, I escaped from the Python shell. Okay, one more time. So we're very quick. Very quick. So input for I in range 100s. So import requests, and from bs4 import beautiful soup, and Ctrl-D. All right, and if I now print buffer, yes, that's because I actually I forgot to say append. So I need to say buffer.append and whatever we have in this input. So again, import requests from bs4 import beautiful soup, Ctrl-D. And now if I print my buffer, that already we see that actually there are 2 lines, but examining the buffer in this way is not really that kind of good way of doing things. So we can write another one-liner to actually print this. So I can say for I in range and the length of the buffer itself. So here I want actually to print, and I want to print like buffer indexed by I. I want to print stringify version of the I itself, which is the line number, and +1 because of the indexing begins from 0. And I also want to have the tab in between, so that it's like the columns are strict. So here we go. But here's another little bit annoying thing, that we have this none down below, so I don't want that. And one of the simplest way of doing this, I just can say exec, so execute, and execute this as a string. So now we have this nicely printed output. So already we've just implemented a tiny little command, believe it or not, which prints the buffer. And before this, we did command that this command that does append to the buffer. We can also manipulate this. You see, if we want to insert to the buffer, like in between, then instead of appending, we say insert and then where to insert. But it's not something we want to do now. So now we actually do want to append again, and yeah, it would be just appending. So I skip one line, so just pressed enter, and now let's say response equals to requests.get, and let's say quotes, let's say https quotes.scrape.com, right? And then let's say content equals to beautiful soup, and response.text, and let's print the content to make sure that we actually do have something returns, and Control D to drop. And now again, I'm looking for my print stuff. And you already probably guessed that it would be a good idea to put this print buffer to a separate command. And that's something that we'll do a little bit later. So I just first want to get done with the program, and then I'll show you this. So you know that we just, so I did manage to input the new line, but just pressing enter and skipping the input, which is another good thing. But actually, yeah, let's say I don't want to I don't want to append, but I want to insert. So between line 5 and 6. So in this case, I can say buffer.insert. So for I in range, let's have this 100 as well. So we're going to be inserting at -1. And this just goes after the content equals beautiful soup and just right before the print content. And here the input, so whatever user type. So this is going to be our insert function. So we already have 3 functions. So the first one is print, append, and now we just made insert. So let's say I want to extract the quotes. And here I say quotes is equal to content dot find all, and I'm looking for span tag with a class. So hold on a sec, I forgot. Span tag and class equals to text. So this should work. And then I want to say for quote in quotes, I want to print a single quote, right? And Control D, and let's print what we got. Here we go. All good, but we don't really want the very last line. So if I say buffer -1, yes, I just want to delete buffer -1, and yes, now we just got rid of our buffer -1. Now, obviously, if this was a regular text editor, you would just go like storing this and then either invoking the shell like Python 3 and this file from like in VI, you can do like execute the bash command. In the GUI editors, you would most likely just open the terminal and run this. Well, in ID, you have this terminal built in, but anyways, the principle remains the same. But here, because we are already in this basic environment, basic shell environment, what we can do, we can actually execute this entire thing. So I can simply say execute, and then I can join by the new line my entire buffer. And what we just got our program being executed. We just got all those codes. But the problem is that we actually want to have we don't want to have the HTML tags, right? So instead we want to only extract the tags from this quote. So let's go print this again and find the line. So actually the very last line, instead of print quote, I want to say I print quote.text. So like an example of how this can be done. So for instance, buffer -1, so this is the very last line, and it's going to be equal to buffer -1 dot replace. That's how I'm performing the actual editing. So we can replace this this parenthesis with I want to say dot text and parenthesis, like so. Okay, and let's print this again. And yes, close.text. So now we can already execute. So which one to execute? Which one? Yes, this one. And bam, we got the quotes being stripped from those HTML tags. So far so good. So we already have a working code. So what we want to do now, we actually want to write this to the file, right? So another operation, but bearing in mind the fact that we are still in this basic environment, no captive user interface. So still Unix philosophy principles are still working. So what I can say, let's say with open, and let's call it scrape.py. Want to write to the file stream as file, and say f.write, and I want to write. I want to join the buffer, like the new lines, just like what I did for execution, but like this. And now let's say from OS import system as shell, so that now I can execute the shell command. So I can say ls, I have this scrape.py, and if I cat this scrape.py, then bam, I have my file here. So I can also now execute this file like this. I can say python3 scrape.py and get exactly the same result. So far so good. So we are almost done, but I want to give a one step further into this. So now we have a few commands that we've created so far, that every time you're about to be writing, like editing text, you would be implementing these from scratch. And again, this implementation I currently have is not the perfect one, but just to give an idea in regards to how this Unix philosophy works. So what we can do here, we can get our, so you see, like here we just execute things. So for instance, if here I say with open, and let's call it print.py, want to write to the file stream. Well, write to the file stream as f, and saying f.write, and bam, we got our command there. So now let's say shell, that's ls, yeah, print.py is there. So now we can say cat print.py, and here we go. Here is our command. Now let's store the rest of commands exactly the same way. So for instance, the next command we have is append. Well, this is print. This is a custom replace. Nope. So I'm looking for the append command. It takes a little bit of a time to find it. Yeah, this one for instance. So append into buffer, right? So here for instance, I can say like yeah, like with open, let's call it append.py. Want to write to the file stream as file f.write, and here we go. And also we want to insert, so I can say buffer. Well, actually, since we insert, we need to specify where exactly to insert. Yeah, let's drop for clarity. Let's drop it. So just good enough to have these two. So append and this one, and another just for absolute clarity, for absolute like follow up to the Unix philosophy. Let's create one more a little thin. It might seem really naive, but anyways. create buffer. So let's just call it buffer.py. So what this piece of code is going to be doing, just going to be creating the buffer, right? And yeah, another couple of things that we can consider. So for instance, we can create the file called save. So we can create the save one and the open. That should be fairly enough for this principle. So let's say we can say join the buffer, and here I need to duplicate the code. So I actually do say here with open. Let's just define the let's say file.py. I know it's bad thing, so it's better to make it like a variable, like the command line, or like either command line argument or whatever, the argument of the function. But just let's make it like this, right? Is file f.write and yes, and like this. It probably gives me an error because, okay, let's break down. So okay, I have this f.write and this f.write. Oh, I can't. Yeah, so here I need to make it like this. Okay, then so this closes the initial one, and where is, actually it seems like it just worked. So let me quickly, yeah, I'm not going to be implementing the open. It's also possible, but yeah, let's just well, actually I can do, but yeah, okay. Let me quickly check shell ls save. So cat save.py with open as right. Oh, the new line is not being escaped. It's a little bit. Yeah, I really want to cheat here and use VI to fix this very quickly. Okay, still, no, actually I need to, oh man, yeah, if I knew how to use the add command, this could be just very trivial to consider, but since I don't, shame on me, I should have. Okay guys, I'm sorry, I just cheated a little bit. Sorry for this. Sorry, you didn't see anything now. You just didn't see anything, alright? You didn't see how I cheated here. So the new line like this. Yes. No one saw this, right? No one really saw this. So yeah, now this seems to be just okay. So test.py, right, file, yes. And let's also here with open test.py. Well, actually not. Yeah, since I don't provide the file names, yes, this doesn't really make that much of a sense. Okay, let me escape from here. List. So what we have. So let's see, cat buffer.py, and we just create a buffer here. So far so good. So we have append. Yes, we have what? Cat save.py. Okay, we got the save, and that's enough. Yeah, and we got scrape, not on the cards now. Alright, so let's go to Python interpreter back to Python shell, and what I want to do now, so to execute command from file, we can do the following thing. We can say exec. Well, this is a little bit dirty practice because we don't close the file, just for the sake of having a one-liner instead of the function here. But anyways, we can simply say open, let's say buffer.py dot read. So whatever we read from the buffer is getting executed. Now we have the buffer. So far so good, right? Now we can execute our append.py. So it's something like as if I was in the bash shell and as if I've been executing the bash command. This is sort of a similar mechanism. Just the syntax is a little bit different. So here I can say this is line 1 and this is line 2, right? Control D and have a look at the buffer. Buffer has been updated, and now we have a fancy print py. So bam, we got our buffer been printed. Moreover that, we can actually save this, and now if I just go back list, we have the test.py. So cat test.py with our lines that we just created. So this is pretty much all I wanted to demonstrate you guys. So what we just did was actually editing text by following the Unix philosophy and by not violating principles like having the captive user interface as well, unless we do have this captive user interface where we enter the command. But since it's not a command loop but just a user loop, which is essential to do one thing and do it well at a time, entering the text, so this can be avoided. And the rest of this, all the features like printing, like printing the buffer, like what else, like saving, appending to buffer, so they all has been separated to the single file commands, so mostly one-liners, and we can actually use them from within our environment, and we can even create this kind of like environmental variable buffer by just creating using this buffer command. And if the buffer command has an argument like the name of the buffer, then we could have created multiple buffers. Obviously, if we kind of improve every command, like for print, we can give the line from, line to, for save, for open, we can give a file name. Those are absolutely essential. So making another Unix principle, small is beautiful. So making this every tiny little small command really beautiful and really doing to the point, doing one thing at a time, doing it well. Now it does one thing at a time. It doesn't do it that well because it can be improved. But anyways, it does one thing, and that's the most important part here. So that's it from my side, guys. Hope you enjoyed the video, and hope it gets a little bit more clear now, like why the text editors are actually violating the Unix philosophy so hard, and the alternative approach. However, it's obviously you to choose between comfort versus following some core principles. It's really about like how things should be done versus how things unfortunately done practice. And yeah, who knows, maybe we would live in a better world if we would be actually following those principles instead of considering comfort. This is it from my side. Thanks for watching. Until the next time, and take care.